Oh boy.
When I wake up each day, I feel so weary. Try to face the world, but it's so dreary. But I found that special thing that makes me cheery. Time to do music theory. Music theory.
Oh boy.
When I wake up each day, I feel so weary. Try to face the world, but it's so dreary. But I found that special thing that makes me cheery. Time to do music theory. Music theory.
You're watching Adventures in Music Theory with your host, Dr. Robbins. Hello and happy April 21st. I hope you enjoyed getting to hear the lovely Dallapiccola Quartina movement from the Quartina collection again. It's such a jazzy, Debussy sounding movement in some ways, except it's written in that 12-tone style that we've been discussing our past couple lessons, and which I thought we would actually discuss even further today. So I've got the score for the Quartina up here, and I thought I'd talk about some aspects of how Dallapiccola uses the 12-tone row to create this composition, as well as to talk about some of the difficulties we might encounter in analyzing this. Some things are fairly easy, like you may have found that the first row presentation was fairly easy to discern because it's all in the uppermost staff there, and it's done melodically, pitch after pitch after pitch. So that's a fairly easy row to extract from the composition, just like in the Schoenberg Fourth Quartet. that first row that shows up in the first violin is very easy to get because Schoenberg treats the row melodically and goes from pitch 1 through pitch 12 in the row. Dallapiccola is doing the same thing here, and the red numbers are showing you the fixed zero integers for each pitch of the row. Since we're only looking at this movement, I'm making this my prime form of the row. So that would be the first row I extracted, and I would build my matrix on it, which is what you're going to see in the next slide. So here's what the matrix for this piece is going to look like when you construct it on fixed zero integers. And I've got the top row in red letters, in part just because as we analyze, I'm going to do things on the matrix to show the row forms that Dallapiccola actually uses, and I'll be either circling them or putting them in red or colored ink or something to discern that, just to point out that even though a composer creates this matrix that has 48 possible row forms, the chances of finding them all used in a composition, especially a tight composition, are not going to be all that great. So we're going to see Dallapiccola using just a few row forms here, but this is my matrix. It's a fixed zero integer matrix, and if I was labeling row types, I would use that fixed zero labeling. So I would call that red row of numbers going across the top there, that would be P10, prime form starting on fixed integer 10. And when you run it from right to left backwards, it would be R10. And when you start in the upper left-hand corner and go from the top to the bottom, that would be I10. And going from the bottom to the top in that row would be RI10. So you all already knew that. Let's go ahead and start digging into this piece. This is the first few measures of the piece, and I've got the matrix set underneath it. Hopefully everything's going to be large enough to where you can read it, because this is how I'm going to do most of this. But like I say, we can put our fixed zero integers in the score, and then we might want to put a label at the beginning of that row form designating that it is prime form starting on fixed zero integer 10. So that's how the start of an analysis of this work might look. We haven't actually talked about how to mark up the score for a 12-tone analysis, so this is one way you could do it. And of course, having the integer numbers written underneath the pitches is probably not something I'd actually do in a real analysis. I'm doing it for us so we can see where they are, but once they go to live in the matrix, then when you're analyzing, really all you need to do is write the row form at the beginning, like I've done with that P10 there. So let's go figure out what's going on not in that upper staff, but in those lower two staves. And that's where it's going to get tricky. And the reason it's going to get tricky is because Dallapiccola is going to be doing that thing where he writes chords. And chords are difficult to analyze using a 12-tone row, or any numbered tone row, because the row sets notes up one pitch after another. A chord like the very first chord we see in the second measure there doesn't have notes set up one after another, so it's tricky to figure out how to analyze it. But we go and let's look at that first chord in there. And that first chord has an E flat and a B flat and a C and a G. So since we're doing fixed zero, let's think about what those numbers are. The E flat's 3, the B flat's 10, the C is 0, the G is 7. So when I was trying to figure out what row form I was dealing with, what I might do is just look around my matrix, hopefully starting at the edges, since we'd like to think that's the beginning of a row, and figure out, so where is there a 3 and a 10 and a 0 and a 7 all clumped together? And if I look at the matrix, ooh, well there's one right there at the bottom. But not so fast, because there's another one. Uh-oh. So there are two rows that have some combination of 3, 10, 7, and 0 at their endings. One of them ends 0, 7, 10, 3. The other one ends from the top to the bottom 10, 3, 0, 7. And it gets worse, because if you look further in, you realize, ooh, and there's also another one starting on the second note of an inversion row, 3, 7, 10, 0 in a row. And next to it, there's another one starting on the second note of a prime row, 7, 3, 0, 10. So, oh boy. So we have to figure out which one of those is fair game. Because depending on which one I go with, that's going to give me 4 different possible rows I might be dealing with. Well, the way to figure this out is perhaps look at what notes come next. And I see that the next chord that shows up in the next measure has a B flat, the B flat's really left over, and an E natural and a G sharp. So that's a 10, and then the E is a 4, and the G sharp is an 8. So what I might do is look around my 7, 3, 0, 10 clusters and see which one has a 4 and an 8 next to it. And when I do that, I realize that that one in the lower right-hand corner that goes from bottom to top looks the most promising. 7, 0, 3, 10, 8, 4. That covers all the notes that he's stated in the right hand there. So apparently if he's doing a row form from bottom to top, he's doing a retrograde inversion form. But let's not go too fast. Let's check and see. Let's look at what's in the next sonority there. Going into the 4th measure, that chord's got a B and an F and an A. And the B would be an 11, and the F would be a 5, and the A would be a 9. And if I look at that retrograde inversion row, I notice that the next 3 notes in it are a 5 and an 11 and a 9. So, aha, this is probably the row we're looking at. We just need to check the ending, because the ending of this row is 6, 2, 1. 6 is F sharp, 2 is D natural, and 1 is C sharp. And if you look at what's going on in the last chord on this system, that chord's got F sharp and D and C sharp in it, plus the E sharp, which is left over as the F from the chord before. So there we've got our complete row, the one that goes from the bottom to the top. So if I wanted to label it on the score, remember you label retrograde inversion rows for the pitch you'd hear last if you played it. So that would be the top pitch. So we're going to call that row RI1. So we unscrambled that. That's part of the art of doing this, is looking at the simultaneities or the chords and figuring out where they could come from. And we're going to have to do that a few times in this piece. So let's keep going. Okay, so the matrix now shows the 2 row forms Dallapiccola used in those opening 5 measures. The P10 row that goes across the top of the matrix and that he used in the uppermost system as the melody. And then the RI1 row that goes from the bottom to the top, and it's in that red box there. And he used that to build the chordal accompaniment. And then this is measures 6 through 9. So let's see what Dallapiccola is doing here. And again, if you look at just the upper pitches, the top 2 systems that are, or the top 2 staves that are written in the treble clef, they're a row form that's fairly easy to decipher. So you go through and you just, I've gone through and put the red fixed do integer or fixed 0 integer numbers on them. It's 6, 11, 2, 9, 7, 3. And then, again, we'll look around our matrix and see, are there any row forms that start 6, 11, 2, 9, 7, 3? And sure enough, there is one. It's a retrograde inversion form on the bottom there. So it's the retrograde inversion form that starts on 6 and ends on 0. So we would call it RI0. And that's what he's using melodically there. Which leaves us to deal again with the chords that are happening in the bass staff, in the lower of the 3 staves. So we're going to do the same thing we did in measures 1 through 5. We're going to look at the chord clumps that happen in the left hand and figure out what row types they could belong to. So the first little clump of notes there is that chord in measure 6 that has an E and a C and a G and an A. When I turn those into numbers, that would be a 0, well, a 4 and a 0 and a 7 and a 9 going from the bottom to the top. So let's look if there are any row forms that start out with some form of 4 and 0 and 7 and 9. And there are a few of them. There's the one in the lower left-hand corner there at the bottom. There's one in the upper right-hand corner about 4 rows down. And then there are a couple embedded. Well, there's actually one that starts on the right side. No, it's embedded there, right? Second column from the end, and there's one about 5 rows up from the bottom, second column going on over. So one of those might be our candidate. Probably one that actually does start at the end, since it would be the beginning of a row form, so maybe not the ones that happen in the middle. And the way to figure out which one is look at what's coming up next. That little green box that just popped up shows you the notes you might want to look for next. It's a D sharp, which is 3, and a G sharp, which is 8, and a D natural, which is 2. So maybe look after those 4, 9, 7, 0 clumps and see if there's anywhere where there's like a 2 and a 3 and an 8 coming up next. And if you do that, you realize that the one that starts on the right side, 4 rows down, you know, right after that thing, we see a 2 and a 3, or a 3 and a 2 and an 8 happen really quickly. And if we look at how this ends in the last measure on that line, in that little yellow circle, there's an A sharp, which is 10, and an E sharp, which is 5, and a C sharp, which is 1, and an F sharp, which is 6. And that row that we're looking at ends 10, 1, 5, 6. So apparently that's the row Dallapiccola is thinking about, perhaps, the one that starts on 0 on the right side and ends on 6 on the left side. And I know if we were in class, you might be raising your hand going, wait a minute, you're missing something. There's an E, an 11, in the middle between those two chords, between the one in the blue circle and the one in the green box. That note's not showing up in the left hand in the chords, and you're correct. So look on Dallapiccola's score between the blue oval and the green box, and notice what happens. Up there in the melody, that note's pulling double duty. There's a B, which is pitch 11, which is the pitch we're missing. And Dallapiccola is using it not just as the melodic pitch in the row form that's going on in the highest staff, but he's also thinking of it as the pitch that comes between that blue oval trichord and that, or tetrachord, and that green box trichord. So that's our row form, starting on 0 on the right side and ending on 6 on the left side. So it would be what we labeled R6. Isn't this fun? Let's keep going. So now we're up to measure 10, and you can look and see that on the matrix it's gotten a little bit more involved because I've got two rows that are red letters to show us that he's used those, and then I've got 2 columns in red boxes to show us he's used those. Right now he's used a prime form, a retrograde form, and 2 retrograde inversion forms. So let's keep going. Let's look and see what he's playing with now. And usually that uppermost staff is a horizontal presentation of a row. So there are our fixed 0 integers for the C, G, E, A, B, D sharp, which would be 0, 7, 4, 9, 11, 3. On we go. So if you look at 0, 7, 4, 9, 11, 3, you realize, oh, we just did that. That's R6. That's what he was using to build the harmonies from in the measure before. Now he's using R6 melodically. And we know how to do the chords, right? We're going to throw some lassos around them here. So let's look at our first chord. It's A, D, F, B flat, or 9, 2, 5, 10, if you want to think about those as fixed 0 integers and stuff. So are there any rows that start out with 9, 2, 5, 10? And actually the very, very first row has that. But so does the second column. So that gives us a little bit to think about. But let's look at what shows up next. In that red box, it shows us what's in our next chord, a D flat, which is 1, and a G, which is 7, and a C, which is 0. So let's look and see which one has a 7 and a 1 and a 0 next. And it's not the top row, but if you look at the second column, you realize, well, yeah, 7, 1, 0, G, D flat, C comes next there. And if we keep going, that little blue circle says that the next note should be F sharp and E sharp, and B, or 6 and 5 and 11, or excuse me, 6 and 4 and 11, because that's E natural. There we go. And it should end with a D sharp and a G sharp, or an 8 and a 3. And it does. So that we did that row from the top down, so we're dealing with an inversion row, the one that starts on A, so we're going to call it I9. So that's that row form. Okay, so our matrix is a little more involved. Now we've got 3 columns in red boxes and 2 rows in red letters. And this is the end of this rather short little movement. So let's again look at that uppermost staff first, the one where he tends to like to do horizontal presentations of rows. Put some fixed 0 integers under this. C, D flat, F, A flat starts out 0, 1, 5, 8. And you can go through and figure out, so where's there a 0, 1, 5, 8 row in this thing? And you realize that, well, there's a 0, 1, 5, 8 row in this. Going from the top to the bottom, it's I0. So that's what he's using melodically there. So it's a row form he's used before in its retrograde inversion form. Now he's using it in its inversion form. And now we just look at our chords. So let's put our little blue oval around that first chord that has E and D sharp and G sharp and B, or 4 and 3 and 8 and 11 if you want. And figure out, is there anywhere on this that we can find 4, 3, 8, and 11? And I see it in the top there, starting on 3 in the top row, but I also see it starting on the bottom row, 4, 3, 11, 8. And if I look at what should come next in that red box, D flat, G flat, C natural, that would be 0, 6, 1. And I realize that if I look at that bottom row, after 4, 3, 11, 8, I get 6, 0, 1. What comes next? That little green circle says that what comes next is G and F and D and B flat and A. So I see, let's see, well, G is 7, D is 2, F is 5, and B flat is 10. So there, that's our row. And again, it looks like we're missing a note. But the note we're missing is also the one that I chose to not label at the very top there. There's a purple triangle around the number 9, which is A, and the note that I didn't account for in that top staff that would throw things off is that A right there in the purple triangle. If you look at it, it's pretty clear that the way Dallapiccola is using it is he's using it more as part of that chord that's happening right on beat 1. And the melodic line is actually that F flat at the end of the measure before it going down to those E flats on the 16th note triplets. So that's how we do this. And look, we've gotten all of our row forms labeled now because that last row form that Dallapiccola did going across the bottom was P4. So looking at this matrix, you realize you don't need a lot of row forms to write a lot of notes. And Dallapiccola does a good job of just using a few row forms, but using them in different directions and using some of them horizontally and using some of them vertically to build chords to make this piece work. And I do think it works. Ready for something new? This is the matrix from our old pal Schoenberg's string quartet that we looked at last week. And I've done something a little bit odd to his matrix. This is a pitch class matrix. We're just using letter names here. But I've put some of them in yellow. I've put the first 6 notes in the top row in yellow. First 6 notes of a row are called a hexachord, by the way. That's what you call a 6-note grouping. And then if you look at the third column from the end, I've put the first 6 notes in its hexachord in yellow as well. You'll notice that those 6 notes in the hexachords give us all 12 pitch classes, even though we're not just using one of the rows off of the matrix. We're not using a prime row or a retrograde row or an inversion row or a retrograde inversion row. Instead, we're actually using a couple pieces of a couple different rows. We're using part of a prime row and then we're using part of an inversion row. And if you did that, you could actually wind up creating a new row form in a composition. So if you didn't want to just be writing the same row and its inversions and retrograde inversions, if you wanted to make a new row when you were composing a piece, you might find an opportunity in your matrix to do something like this. And suddenly, you'd change the way the row sounded, right? Because if I play the first hexachord and I go D, C sharp, A, B flat, F, E flat, the next note that's supposed to happen is a half step, E. But if I jump to that hexachord in yellow going down, then I'd be changing what happened in the row, and I'd be putting in suddenly a major third skip from E flat to G instead, and I'd be adding a new ingredient in. And there's a name for this. And the name for this is combinatoriality. It's a nice big word, and I will spell it for you. Here's the matrix again expressed in integers instead of in pitch classes. Sometimes I find it easier to see everything getting used up using integers because it's always just 0 through 11. So you can see that the first hexachord of that top row and the first hexachord of the third to the last column give us all 12 pitches, an aggregate. So we would say that these two hexachords are combinatorial. And combinatoriality is simply this. It's combining a portion of one row with portions of another row or other rows to create complete groups of all 12 pitches, to create aggregates. And there are different types of combinatoriality going on in the world. For instance, since this particular thing we're showing here involves taking part of a prime form hexachord and combining it with part of an inversion form hexachord, we would say that this exhibits what we would call inversional combinatoriality, which means you can combine the prime row with an inversion row to get an aggregate. Since we do it using 6 pitches from each row, we would say it's an example of hexachordal combinatoriality. There are other possibilities out there. Not only is there inversional combinatoriality, there's also retrograde inversional combinatoriality, or what they call RI combinatoriality. There's retrograde combinatoriality. And it's not always taking half of one row and combining it with half of another row. Sometimes you take like a 4-note section of one row and combine it with a 4-note section of another row and a 4-note section of another row, and that gives you what we call tetrachordal combinatoriality. And this thing here, once I put a matrix with it, is going to be something that we would say demonstrates trichordal combinatoriality, because I've got these trichords colored different ways, and you can see how I could, depending on which color group I look at, I realize that that trichord lives not just in that prime row going across the top of this matrix, but it's also nested at the bottom or in the middle perhaps of that inversion row going up and down the middle of the matrix. So if you're combining 3-note pieces of a row, you're doing what we call trichordal combinatoriality. And it might work like this. Like there's that little weird looking equation written at the top of the page there. Show that to people if you want to scare them. That says P11 plus I6 plus RI6 plus R11. That's how we might think about combining different trichords from different rows to create a new row form. Because if I look in P11, which is at the top there, starting on 11, that's the first trichord in the yellow right there, that 11, 10, 2. Then let's look down in inversion 6. Its first trichord is the 6, 7, 3. And let's look at RI6, which is the bottom of that same thing we were looking at, which would start out 8, 4, 5. And then let's look at R11, which is the row on the top there, but starting at the end, going 9, 1, 0. So if I combined all of those, I could get a new row form, that thing that's in the little box at the bottom of the page there now, showing you how suddenly I'd have a new row form where instead of going 11, 10, 2 and then up a half step to 3, now I'd be going 11, 10, 2 and then up 4 half steps to 6. So I'd be changing up the sound of the row and creating new rows, but they would still be rows that had their origins in the original row forms, and that would help unify the composition. And you don't have to start at the beginnings of row forms to make this work. There's that equation cooked a little bit differently. We were saying now, what if we went to that top row to P11 and used the second trichord, the 3, 7, 6 part of it? And what if we went to the I6 row and combined the fourth trichord of it, the way it would end, the 5, 4, 8? And what if we went to our top row up there, the R11, and used its beginning trichord, the 9, 1, 0? And then we've got our RI6 trichord down there. What if we took its third trichord, which is the 11, 10, 2? And again, in that box at the bottom, we could put down a new row form that came about through taking trichordal segments from the given rows in the original matrix, and we could make new row forms. And of course, if you want, you could even then make a brand new matrix using that new row form, because there aren't enough matrices in the world. Okay, and now I'm going to fry your brains a little bit. What we're looking at here is a composition by Milton Babbitt from 1966 called Play on Notes. It was originally intended for children's voices and handbells. I've looked and I can't find any recordings that have been made of children singing it and handbells playing it. If you look on YouTube enough, you'll find some guy delivering a theory paper who does play the bell part on guitar and gets somebody to come out and sing the vocal part. I don't have my speaker here, so I can't play it for you, but it's out there if you want to hear it, if you get curious. This is a 12-tone composition, and it's built in kind of an interesting way. In fact, if you look at the vocal part, let's look at that second staff. It looks like it might be okay as far as getting children to sing it, because you realize, oh, it's all white notes and stuff. It's all natural pitches a lot of the way through. And it's just C, D, E, F, G, A. It's a hexachord. It's not even a complete scale. It's only near the end of the piece that suddenly some black keys like E flat and B flat and D flat start showing up in the vocal part. But for the most part, he keeps the vocal part on just those 6 white notes, C, D, E, F, G, A. And then if we look at the bell part, you'll notice, oh, the bell part is made up of mostly black notes. G flat, A flat, B flat, D flat, and E flat. That's 5 notes, and the only thing that's missing is B natural. And that's also a major scale hexachord. You know, think about that B flat as C, or that B natural as C flat, and you realize, oh, well, that's G flat, A flat, B flat, C flat, D flat, E flat. It's a hexachord of a G flat major scale. So he's built his row out of 2 different major scale hexachords here. One C major, the first 6 notes, and one G flat major, the first 6 notes. And that's what his row comes out of, because those 2 hexachords create an aggregate collection of all 12 pitch classes. So here's what the matrix for this piece would look like, and I'm just going to use letter names on this today. There's no reason to use numbers for a piece like this. That's our matrix. And I'm going to show you some interesting properties of this particular matrix. Look at the top row, the P0 row that starts on C, and look at the bottom row, the R0 row that starts on C. And realize that the P0 row, when you read it across from left to right, goes C, E, F, D, G, A, E flat, D flat, A flat, B, B flat, G flat. And realize that the R0 row, if you start from right to left and read it, goes C, E, F, D, G, A, E flat, D flat, B, A flat, B, B flat, G flat. Exactly the same. P0 and R0 are the same thing. There's no difference. You couldn't tell them apart if you heard them. the pitches come in the exact same order, and it gets trickier. Like look at the second row down that starts on A flat. That would be P8. And look at the second row from the bottom. It starts on A flat as R8 when you go from right to left, and they both end on D, and they're the same. Third row down starts on G, starts out G, B, C, A, D, and the third row from the bottom, if you read it as a retrograde, starts out G, B, C, A, D as well. Fourth row down starts on B flat and ends on E, as you do it as a prime form. Fourth row from the bottom, if you do it as a retrograde, starts on B flat and ends on E. Same thing. And the color coding is showing all the rows that are identical. The fifth row down starts out F, A, B flat, G, C, D when you go prime form. Fifth row from the bottom starts out F, A, B flat, G, C, D if you do it as a retrograde. And then those two rows in the middle that start on E flat and end on A are also the same. So this is an interesting matrix, because when you look at your prime forms and your retrograde forms, you realize there's no difference in them. For every prime row, there's some retrograde row that sounds exactly like it. And if we looked at this thing vertically, you'd realize the same thing. For every inversion row, there's a retrograde inversion row that sounds exactly like it as well. Which means for all intents and purposes, there aren't 48 different row forms going on here. There are only half that many, so we could really rule out all that stuff in that box on the bottom. Your brain may not be frying yet, and that's fine, but we'll get there. Let's go on to the next slide. Here I've gotten rid of a lot of the matrix. I've gotten rid of, really what I've gotten rid of is this. I've gotten rid of all the row forms that we're not going to be seeing show up at all in this piece. So I'm going to keep just this little sort of T-shaped type thing, and I'm going to use it to analyze the piece. So let's go on to the next slide here. All right, and here I've actually pared that matrix down even more to where there's just one horizontal row that's a prime or a retrograde row, and one vertical row that's a inversion or a retrograde inversion row. And let's just see how much of the piece we can analyze with that. So looking at the vocal part first, where he goes C, E, F, D, G, A, that's actually the first half of that prime row. So let's call it prime row 0, hexachord 1. And if you're wondering where's hexachord 2, the part that goes E flat, D flat, A flat, B, B flat, G flat, there it is in the bells on top. So what Babbitt likes to do in this piece is combine hexachords from different row forms to create aggregates. And that'll get a complete row form out there, and he'll get all 12 pitches out in the first two measures. The other thing that's neat is notice how by combining those row forms, all the intervals that happen harmonically are consonant. The C to E flat's a minor third, the E to D flat is an enharmonic major 6, the F to A flat's a minor third, the D to B's a major 6, the G to B flat's a minor third, the A to G flat is an enharmonic minor third. So he's getting a lot of consonant intervals from this in those first two measures. And that's part of what helps this piece have sort of its charm and have a prayer of being a piece that children can sing with bell accompaniment, is that he does write a lot of consonant intervals. And if you look at measures 3 and 4, you realize that the next thing the voice does, it goes A, F, E, G, D, C. So where would I find that happening? Well, if I start in the inversion row and look at the first hexachord, that's what's happening there, the inversion that starts on A, so I9. And going on top of that is G flat, A flat, D flat, B flat, B, E flat, the second hexachord of inversion row 9. So again, he's combined two different hexachords to get an aggregate. Going down into measure 5, same thing. Look at that inversion row, and it's actually the second hexachord of RI 9. C, D, G, E, F, A, combined with the second hexachord of inversion 3. G flat, or excuse me, the second hexachord of R0. G, B flat, B, A flat, D flat, E flat, spelled enharmonically this time. And then At the end of the line, he combines the first hexachord of RI 0 or RI9 there, E flat, B, B flat, C sharp, with the second hexachord of retrograde or retrograde inversion 9, which is that AG, excuse me, sorry, it's the second tetrachord of R0, that AG DFEC. So it's another aggregate that's been created. And then measures, what is that? Measures 9 and 10. It's the same thing as the first two measures. It's the first and second hexachords combined of the prime row that's up there. And then he switches and he actually has the bells move to the white note collection and the voice move to the more black note collection. So the vocal part's going E flat, B, B flat, which is that retrograde inversion 9 first hexachord. And the bells are going C, D, G, F, E, A, or G, E, F, A, excuse me. And that's the second tetrachord of retrograde inversion 9. And then at the bottom, the voice goes C, D, G, E, F, A. That's the second tetrachord of RI9. And the voice, excuse me, the bells go G flat, B flat, B. And that's the second tetrachord of retrograde 0. And then at the ending, the bells go A, F, E, G, D, C, which is the first hexachord of inversion 9, and the voices end E flat, D flat, A flat, second hexachord of P0. All of these hexachordal combinations form aggregate collections. So that's the pitch aspect of this, and that's not the part I mean to fry your brain, but what's going to fry your brain is coming next. Here's where it gets more interesting. You'll notice that there are places where only certain notes happen and stuff after certain things, like there tend to be, you know, C, D, E, F, G, A natural are all grouped together. G flat, A flat, B natural, D flat, E flat are all grouped together because of the nature of the row and the hexachords. There are other things that happen consistently though. Let's circle some stuff. Those red circles are all circling, depending on what you focus on, they're either all circling the note C or they're all circling the word here. Sometimes meaning the place, stand right here, sometimes meaning to listen to or to hear something. You know, it's a homonym, but that's okay. You know, we don't get upset in this piece when he says D flat instead of C sharp or something, so we're not going to get upset when he says H-E-A-R instead of H-E-R-E, but interesting how the word here, in whatever form it is always a C, and it gets better. Notice that the word play is always the note E. And notice that the word and is always the note F. And the word note is always the pitch D. The word the is always G. And the note A is always the word sound. I bet y'all weren't even aware that this piece only had 6 words in it. So the words become their own little hexachord. And what Babbitt's doing is he is sort of serializing words, lyrics, as well as pitches. By the way, you might be sitting here going, wait a minute, what about those last measures where the voice starts singing black notes instead of white notes? There are some boxes that are color-coded. You'll notice that whenever there's like a black note version or whatever of those notes, it's always a tritone away from the original one to show the distance between the two hexachords of C flat major and G flat major. So when he says here in the parts where the voice is not singing C, it's always going to be singing a tritone away from C, a G flat. The word play, if it's not an E, it's going to be a B flat. And you can check all that out by looking at the color coding there. So Babbitt has taught us something kind of interesting and brain fryish, to wit, that you could actually serialize stuff that wasn't just pitches. Here Babbitt has found a way to serialize lyrics. And that brings us to our next topic. Our next topic being what's called integral serialism, also known sometimes as total serialism. And it's this idea that composers come up with after the Second World War, that you can use a matrix to create a series for pitches, but you could also serialize things in music that aren't the pitches. And we saw Babbitt just did that with the lyrics a little bit. You know, the way that the lyrics happened wasn't just by writing words to convey thoughts, but it was also by like letting those words be attached to certain notes in the hexachords. Well, composers decide you could serialize other stuff. Yeah, sure, we serialize pitch. That's why they started that, to like not write music that had tonal centers, but they realized just like you can put your pitches in a row or in order, you could put your rhythm in an order, or you could put dynamics in an order, or you could put articulation in the mix to serialize, or timbre. There are all sorts of different ways that this can happen. And I've threatened to fry your brains today, but really I'm going to probably stop it there, and I'm going to fry them real good when we get back together on Thursday. So here's some things I want you to do before Thursday, though. There's a little homework here. The new thing we talked about today that I think you're ready to deal with is combinatoriality. So I have a matrix. It's on Moodle and it's on Google Class. And I want you to look at that matrix. It's a matrix that demonstrates tetrachordal combinatoriality. That means you can take different row forms and extract 4-note tetrachords from them. Right? A tetrachord is going to be any 4 pitches in a row. So I want you to look at that matrix, find places in different rows where there are tetrachords that can be combined to create new row forms, and then create some. And explain to me how you're doing it. You know, so for instance, you could say, here's a new row form I made, and what I did is I took the first tetrachord you'd play in retrograde 6, and I combined it with the second tetrachord you'd play in prime form 8, and I combined that with the first tetrachord you would play in inversion 3, and that gives me a new 12th note aggregate row. So, like I say, that's on Moodle and on Google Classroom. So look through that matrix and see if you can create a few new row forms. A few meaning like 3 or 4, and make them things that happen from tetrachordal combinatoriality. You might find there's trichordal or hexachordal possibilities as well, but I'm interested in tetrachordal. And the other thing too is remember that there is a test coming up on April the 30th, which is not this Thursday, but a week from Thursday. So this Thursday we will talk about total serialism. I'll give you a little bit of the history on it. We'll look at a total serial piece. We'll weep. And then we'll get back together on Tuesday and we'll talk about study and what's going to be on the test on Thursday, April 30th. So have fun until then. Hit me up with the questions if you have them. Once you've gotten your row forms, email them to me so I can grade them. And the row forms don't have to be written out in notation. If you find it easier just to write out integers or letter names or something, that will be fine. Okay, so enjoy yourselves. I will see you next time.